Welcome back, students. We're going to be talking right now about solving simple equations. First, we're going to be focusing in on how to use addition and subtraction. Then we'll be moving on to multiplication and division. Finally, we'll see some examples of how to use this in different contextual problems, different word problems. So first, we've got this equation right here. X minus 3 is equal to negative 5. In order to figure out what X is, we're going to need to eliminate the minus 3 we have right over here. We want to get just X equals. And that's how we know when we've solved it, when the variable is alone on only one side. The way we're going to get rid of this minus 3 is by using an inverse. An inverse is just going to be the opposite operation. Because this was minus 3, we'll do the opposite of that, which is plus 3. Now, the reason why we can add this 3 to both sides is because of the additive property of equality, which essentially states that if you add through the same number to both sides of an equation, then it's going to remain the same amount on both sides, that both sides will remain equally as large. So this side got bigger by 3, but this side also got bigger by 3. So regardless of what it was before, both sides are still the same because they got bigger at the exact same time by the same amount. Now, we've got this minus 3 plus 3. Minus 3 plus 3 is just 0. So x plus 0 is just x. Negative 5 plus the 3 equals a negative 2. So now that we've simplified that, we're going to check it. We're going to make sure this answer is right. Now, with a lot of the equations I'm going to show today, there's not much room for error. We're going to be reasonably certain that we got the right answer. But this method of checking your answer is really important for you to learn, especially as the equations become more and more complex. And the likelihood that you could have made a small mistake rise up. So here's how we check our answers. First, rewrite the equation exactly like it was at the beginning. Next, we're going to change our variable to the answer we got. In this case, x was a negative 2, so I changed x to negative 2. At this point, we've got just simple math expressions that a calculator can even do for us. Negative 2 minus a 3 is a negative 5. Negative 5 equals negative 5, so both sides are the same. This is true. I know my answer is correct. Let's see another example. We've got 0.9 is equal to y plus 2.8. I'm going to focus in on the right-hand side this time because that's where the variable is. So I need to get rid of this plus a 0.8, 2.8. Opposite of adding is subtracting, so I'm going to be minusing a 2.8 from the right side, minusing a 2.8 from the left side of that equation. So when we minus over here, that just becomes 0. Y plus a 0 is just going to be y. Anything plus 0 is just itself. 0.9 minus the 2.8 gives us a negative 1.9. All right, now we're going to go over to our check. We rewrite the equation exactly like it was before. We change our y to the variable, to the answer that we just got, so negative 1.9. And now negative 1.9 plus the 2.8 equals a 0.9. 0.9 equals 0.9. That's true. We definitely found the right answer. All right, now this problem is going to be a bit more difficult because now we're moving into multiplication and division. One thing to just remember, this fraction sign really just means divide. This is n divided by 5. We also need to pay attention to this negative. Now, whenever you're trying to eliminate a negative using multiplication or division, we want to remember that a negative times a negative is a positive, and a positive times a negative is a negative. Now, we've already got one negative. If I multiply by another negative or divide by another negative, I'm going to get a positive answer. So that's how we're going to get rid of these negatives that are near the variable. Next thing I'm looking at is this is a division. So I'm dividing by a 5. I want to do the inverse of that, which is multiply. We can do that by the multiplicative property of equality. If I'm going to make the left side 5 times bigger, I need to make the right side 5 times bigger as well. That's the way that we maintain equality of both sides. That whatever we did to one, if the left side gets bigger, right side has to get bigger by the exact same amount so that they stay the same size. Okay, now this negative times negative means our answer will be positive. 5 is going to multiply up here to the n, so I'll have 5n divided by 5. So if I've got 5n's divided by 5, well, that's just 1n. Negative 5 times by a negative 3 becomes positive 15. Now let's go over to our check. Rewrite the equation. Change the n to a 15. Now my 15 divided by 5 is going to equal a 3. And we bring the negative down. It's still there. So negative 3 equals 3. Negative 3. Absolutely true. Therefore, this is the correct answer. All right, now in this one, you'll notice we don't have a lot of numbers here, but that's okay. This pi is a number. Okay, it's representative of 3.141592658, going on forever. But it's still just a number. I don't really want to write all those decimal points. That creates an equation that's way too long and cumbersome to be working with. So we just use the symbol pi. But because it's a number, I can treat it just like any other number. And in fact, that's what most variables are. They represent numbers, and we can treat them like numbers. We just need to remember certain properties of the ways certain numbers would behave with one another. So for example, right here, this represents multiplication. A number that's put directly in front of a variable just means they're being multiplied. So I've got pi times x. I want to do the inverse, which is division. Okay, same thing, it's going to be the multiplicative property of equality, whether it's multiplication or division. Pi divided by pi. Any number divided by itself is always the same answer. 5 divided by 5 is 1. 2 divided by 2 is 1. 1,000 divided by 1,000 is 1. So pi divided by pi is just 1, and then we have that x. So we got 1x. Over here, pi divided by pi is just 1. 2 times 1 is just going to be 2, and we bring down that negative in front. So our simplified answer, x equals negative 2. We're going to go over and check it. We change the x to the negative 2. Whenever you're dealing with multiplication and division, I think it's really helpful when you use your parentheses. It helps us to avoid common mistakes or misconceptions, like thinking that this says pi minus 2, which if we didn't have these parentheses, that's what it would look like. But this was pi times x, so this needs to be pi times negative 2. Now, order in multiplication doesn't really matter. 5 times 3 is 15. 3 times 5 is 15. So this pi times negative 2 can be rewritten as negative 2 pi, which just happens to equal what the right-hand side said. So this is true. Those two sides are equal, meaning that x does equal negative 2. That was the correct answer. Okay, now once again, we're using these inverse operations. So pay attention to what's happening right there. We are multiplying these two together. Even though you don't see the multiplication sign right there, 1.3 directly in front of a variable means 1.3 times z. So the inverse of that is going to be division. This is the multiplicative property of equality. 1.3 divided by 1.3. Anything divided by itself is just 1. So we have 1 times a z. 5.2 divided by a 1.3 is going to be 4. So z is equal to 4. To check our answer, rewrite it. We've got this multiplication right here, so I'm going to put it in parentheses as I switch that up. So 1.3 times by the 4 becomes 5.2. 5.2 definitely equals 5.2. So 4 is the number that z needs to be in order for this equation to be true. Now, when you're approaching word problems, one of the things I like to do is first read through it, think about what's the important information, underline things, highlight things, and then try to relate those variables. Be thinking about what's the important information in this and what's kind of stuff we can just throw to the side. In the 2012 Olympics, Usain Bolt won the 200-meter dash with a time of 19.32 seconds. Write and solve an equation to find his average speed to the nearest hundredth of a meter per second. All right, now, first thing I'm going to do is identify my variables, which is just my way of saying I'm going to identify the useful information here. So one thing that's really important is notice your question. We want to find his average speed. Since that's what I'm looking for, I want to find all the information that's related to figuring out how fast something went, what the speed is. So first thing in this story I noticed that could be related to speed is the distance. He went 200 meters. Next, we know how much time it took him to do that. It took him 19.32. What I'm looking for is that speed, that rate. So that's going to be my variable, my unknown. Now, if I want to relate them, distance is equal to rate times time. And you can just think about that. If I say you were driving at 60 miles per hour for 2 hours, how far did you just go? Hopefully your brain went immediately to 60 times 2 is 120, so I went 120 miles. Okay, we're going to take the rate, which is the speed, multiply it by the time, and that tells us the distance. Now, we didn't have all of these. We were missing the rate. We're going to rewrite this as an equation where I changed my distance to 200, the time to 19.32, and now I solve for my unknown, the r, and that should tell me how fast he went. I notice that I'm multiplying r by 19.32, so inverse of that, divide by 19.32. 19.32 divided by 19.32 is going to be 1, so I'll just have 1r. 200 divided by 19.32 is approximately 10.35, and that's why I changed from an equals to the approximate symbol, because I rounded. The moment you round your numbers, you can't keep using equals because it's no longer an exact answer. R isn't exactly 10.35. It's just really, 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 really close to a 10.35. Now, this is great and all, but it doesn't actually answer the question. If you're given a word problem, give a word answer. We were asked to find his average speed to the nearest hundredth of a meter per second. Well, Bolt ran approximately 10.35 meters per second. And now I've given my answer, and that's done. Let's take a look at this process again using a different problem. On January 22nd, 1943, the temperature in Spearfish, South Dakota fell from 54 degrees at 9 a.m. to -4 degrees Fahrenheit at 9:27 p.m. So only about a half hour later, it had gone all the way down to -4. So how many degrees did the temperature fall? All right, so that's my question. How many degrees did the temperature fall? I want to focus in on all the information in the story that's related to how much they fell. So one thing I started off with is my starting temperature. Starting temperature was 54. Ending temperature was a -4. And what I'm looking for is how much it fell. Now I want to relate these variables. I want to relate all these words in some simple equation. So my start temperature, and then I subtract how much it fell by, should tell me how much the end temperature was. So 54 degrees at the start, subtracting how much it fell should equal -4. All right, now we're going to try to get this F alone. First thing I want to do is eliminate that 54. So I had this 54 over here. It was a positive, so I'm subtracting it from both sides. Notice I subtracted it right here for the left-hand side, right here for the right-hand side. Both sides are going to get lower by 54 degrees. Now, 54 minus 54 is just 0, leaving me with that negative f. Okay, that minus that was in front of the f stays with it. Now, you should have seen from earlier, we saw how to deal with negatives. We can multiply by another negative to make this positive, but we can also just think this one through. If negative f equals negative 58, then what should positive f equal? Positive 58. So the temperature fell by 58 degrees. I hope this helps you, and I hope it helps to clarify how to approach these single-step equations. Have a good day.